Inverse functions. For a function to have an inverse, it needs to be first a one-to-one function. In another video, we went over how to figure out if a function is a one-to-one or not using the horizontal line test. I'll put the link in the bottom so you guys can refresh your memory if you need to. Now, let's say we have a function f of x and we want to find the inverse of this function. So for any function f of x is equal to y, the function g of y is equal to x will be the inverse of it. Now, how do we go from that to from f of x to g of y is through some steps that we will go later. But first, a point that we need to be careful is that the domain and the range of f of x. So if we have the domain and range for f of x, the domain and range of g of y will be like that. So the range of f of x becomes the domain of g of y, and the domain of f of x becomes the range of f of x. They get swapped because we are basically switching them. Now, how we get the inverse function. So let's do that through an example. Let's say that we have the function f of x is equal to 3x minus 2. And we want to find g of y is equal to x, which is the inverse of it. So the first thing is we need to solve for x. So we have y is equal to 3x minus 2. We bring the negative 2 to the other side. It becomes positive. Then we divide both sides by 3. Now we have x is equal to y plus 2 over 3. Now we said that our inverse function is g of y is equal to x, so we substitute the x with the function that we found, and we get g of y is equal to y plus 2 over 3. And that is basically our inverse function. But the last step that we need to do is to change y to x. It doesn't matter if it is x or y, it's just a letter that we assign to, but our standard form is the function of x. So we switch y, all the y's with the x, we get g of x is equal to x plus 2 over 3. And this g of x is the inverse of f of x is equal to 3x minus 2, with the domain and range getting swapped. We got a theorem, round trip theorem, that says that if a function f of x has the inverse g of x, then the f of g of x is equal to x for every x in g, and g of f of x is equal to x for every x in the domain of f. And if this is true, then f of x, first of all, is a one-to-one function, and g of x is the inverse of it. Now we will go to one example to see if this one actually works. So let's say we have the function f of x is equal to 5 over 2x minus 4. And then we have g of x, which is said that is the inverse of f of x. and it's equal to 4x plus 5 over 2x. And we are asked to prove that g of x is actually the inverse of f of x. So we gotta do these two to prove that. So the first one, we say, okay, so g of f of x. Let's do this one first. So how do we do it? We write g of x and we substitute every x with the function f of x. So it's going to be 4 multiplied by 5 divided by 2x minus 4 plus 5 divided by 2x, and then we plug in that function for the x. So 5 over 2x minus 4. Now let's do the multiplication. So it's going to be 20 over 2x minus 4 plus 5 divided by 10 over 2x minus 4. We need to get the common denominator for the numerator, so it becomes 20 plus 5 times 2x minus 4. So it becomes 10x minus 20 divided by 2x minus 4. And then this one stays. So 10 over 2x minus 4. So the 2x minus 4 cancels out. And then here 20s go away, 20 minus 20. Then we have 10x over 10. The 10s canceled out, and then we are left with only x value. Now, if we go ahead and do the f of g of x, so let's do that. F of g of x and see what we get for that. So f of g of x will be equal. So we write the function f of x and we substitute for every x value g of x. So it will be 5 over 2 multiplied by 4x plus 5 over 2x minus 4. All right, so 5 in the numerator stays. We do the multiplication, and then we also need to get the common denominator. So this one becomes 8x plus 10. We get the common denominator minus 8x, the whole thing divided by 2x. So the 8x's cancels out. Then we do the further one, so it becomes 10x divided by 10. The 10s cancels out, and we are left with the value of x. So that proves that first f of x is a one-to-one function, and g of x is the inverse of f of x. Now, the next thing that we need to do is to learn how to graph the inverse functions. So let's say that we have the coordinates here with x and y, and then the first thing that we need to do is to draw the line y is equal to x, and then every point on this coordinate for the graph that we have gets reflected across that line, and that would be the inverse of it. So what does it mean is that, let's say we have the point 2 and 5. So that is 5 and that is 2. So our point is 2 and 5. In order to get the inverse of that point, we go perpendicular to the line, extend it the same amount, and that new point will be the inverse of that, which is going to be 5, and 2. If you remember, we said that the domain and the range get swapped when we get the inverse function. So here we had 2 and 5 domain and range. Now we have 5 and 2 as our domain and range. Now, what if we want to do a full graph, not just one point? We do it the same way. So let me draw another x and y, x and y. And now we need to choose one graph, a one-to-one function that we know that it is one-to-one and it has an inverse function. Let's say y is equal to x cubed. So the function y is equal to x cubed is something close to this. So the first thing that we need to do is draw the x, y is equal to x. And then we are going to reflect every point of the y is equal to x cubed on that line and find the inverse of it. So if we do the first part and we do the reflection, that's how it's going to look like. If you look at it, it's almost getting the reflection according to that line. And for the second part, it's going to be something like that. So the purple line, the purple graph will be the inverse of y is equal to x cubed. And that's how we get the graph of the inverse functions.